Another day. Bright light. Well, that fuse box isn't going to get wired by itself. Guess I got to finish that today. Alright, time to get started. I was asked by one of my students, why is this taking me so long? And there's a lot of things you don't realize. I want to put a power receptacle over on the other side there. And so I've got the box, I've got the receptacle to go in it, and I've got the cover. But I know it's got to face this way, and this is called a knockout. So I have to take that and I have to pull it out like that. Then I have a fitting, and that fitting goes in here like this, and then this locking nut goes in here like that, see? Then I have to set it down, and I have to take a screwdriver and lock that into position. Make sure it's even. Then I have to go over and drill it to the bench, run the wire in there, make the connections, screw this in, and then put the cover on it. And that's just one outlet. I still have to run the wires from here all the way around, and then wherever the wires go, we don't want them to just flop around. So I've got these little plastic pieces here which lock the wire into place, and that helps it to, travel where I want it so it doesn't come loose. And just putting that one outlet in there is going to probably take me an hour. And I've got 1, 2, 3, 4 that I'm putting in. So, and one of them is going to be switched, so the wire has to go through. I have to drill a hole, put a switch in there, and make it so that I can switch that one on and off, because that's going to be for like a little mini air compressor later in the future. And that's just a small part of it, and that's not even wiring up the machine yet. So yeah, it's a long process. The sensors for the home positions are 24 volt sensors. The StainSmart boards that I have, which connect to the parallel port, are 5 volt. Hooking a 24 volt signal into a 5 volt, it would not be so good. The thing about doing this stuff is you got to pay attention. I started to build one, and I got it 3/4 of the way finished before I realized I had the chips in the wrong way. So this time, I'm going to do it the right way, and I am going to populate the board with sockets like that so I can put the chips in, which will also be better because if anything ever goes wrong, I can just pop the chip out and put a new one in. We're going to be using a voltage shifter, and to do this we're going to take a 4N35 opto-isolator and use it to shift the voltage from 24 volts down to 5 volts. This is the 4N35 opto-isolator chip. It has 6 pins, and let me show you the way that we're going to use them. We're going to put a signal input on number 1. We're going to put ground on number 2. We're not going to use pin number 3. Number 4 is going to be our output. Number 5 is going to be a 5 volt input, and we're not going to use number 6. So let's take a look at this. First, we connect a resistor up to pin 1 because inside of the chip is an LED, and 24 volts would destroy it. So we're going to put a 3,300 ohm resistor, or a 3.3K,
resistor on there. Then we're going to connect our home signal, which is either going to be 0 volts or 24 volts. On the next pin, we're going to put our ground signal. Jumping over to the other side, we're going to go to this pin and connect a 5-volt supply. So that way, as the signal either is 0 volts or 24 volts, that LED will light up and it will either switch this 5 volts on or off. So coming out here, we get either 0 volts or 5 volts, which is a safe level to put into the board to read for the home signal. I need my other glasses. Getting old. All right. So let's get these soldered on. Like this. Heat up the tip a little bit. Put a little bit of solder on there. Move to the next one. I'll get the soldering pencil, and this time I'll try not to get my pet fingers in the way so you can actually see what I'm doing. Wet that down. Stick that in. That's good. Then we lay this out to where I want it to go, like that. And we want the cable to be that long, right? And this time I'm going to grab a hold of it with this so that I don't pull the jacket off of it, and come over here and just lightly grab it and pull that little bit of metal off like that. You gotta have patience for this stuff. If you don't, you'll never succeed. Never, never, never. And then we just come in here, a little bit of solder on it, take that off, and there's all the positive wires done for the 24 volt side. Then I've got some black so I can do the grounds. Yay! Got the computer down here temporarily. I got my outlets all wired up. Hey, the computer's plugged in down here. Alright, got the mill pretty cleaned off. And then over here, I got a temporary table set up with the computer. And if you can see here, I've got the parallel ports, twin parallel ports set up. This is for this is for steppers X, Y, and Z. And then over here, this stuff here is all for the spindle, because I've got those 3 codes. So if I come in here and tell it to go ahead and turn this on at 1,000 RPM, that's going to kick it into the first band, which is 10,000 RPM. And that's spinning. That's how quiet it is. And now we'll come over here, we'll do my maximum speed of 25,000. And that's full speed at 25,000. And then I'll turn that off. And then over here we've got a test file. And if I tell it to run, off it goes, fully functional. So I just have some fine tuning to do, and it'll be ready. So yay for that. Whew. So this thing had all this old MDF on there. And the MDF had its advantage. You could just drill into it with your screws to hold stuff down. But if it got wet, it just spudged out all over the place. And since I intend to cut aluminum on here, and we may use wet cutting, I can't have MDF. So Wolf, what are we doing, man?
Replacing the MDF with PVC.
PVC. And this stuff doesn't care if it gets wet. Wolf just cut these down, and so they should just drop in and screw right into place.
Alright, let's see if the holes line up. It's not lining up. That one's lining up. This one's not. Yeah, maybe I don't. Well, you know what? Let's flip it around and see if there's a discrepancy in the holes. Alright, that one fits. That one fits. And nope, that one still don't fit. Wait. How far is it off?
So the whole follow.
Yeah, wait, yeah, hold on, wait. If I can get it started, maybe it'll just tighten down. Probably off by a quarter millimeter, maybe. Maybe we need to make these inner holes just a hair bigger.
Yeah.
Yeah, okay. I mean, the worst that would happen is we'd end up having to put a washer in there, you know? But I don't think we need to. Is that even a bigger bit? It feels like,
Big enough material.
yeah.
Not a lot.
Well, let's see. Let's see if it works. Yeah. Word out! Yeah, this one's like it's off to the side slightly. Yeah, let me just make an oval out of it. We're building a precision machine. What I should have done is I should have put a bit in there, lined it right up with the hole, brought it up, put the piece in, and just went nyeh. Because I could have done it. It's actually moving now. Oh well. So this is the current condition of the box. It's mostly functional.